Hi everyone, Dr. Vaughn. I'm going to make a very quick video. I've actually already done the problem, but I just wanted to point something out to you. This is regarding activity 13.4, Excel activity 1. And so when you actually run this and you open up the spreadsheet, it'll open it up in this online version of Excel where you have to have added the data miner tool pack. But what I did is actually cut and pasted it out of this online Excel version where I don't have the data miner tool pack installed. And I just pasted the data into a regular spreadsheet where I do have the data analysis tool pack already installed. So that's just my first step, is cutting and pasting out of the online, because I don't like using this, into just the ground-based, the installed version of Excel that I have on my computer, because I'm more comfortable using it. Now, the second thing then I did is I ran an Anova, a two-factor without replication. So what I did is go to the data analysis tool pack and find the two-factor without replication. It's without replication because these are separate scores. So for system A, controller 1, there's only one score. For system A, controller 2, there's only one score. You don't have multiple scores in each of these kind of two-factor cells. So two-factor without replication. And then when you click OK, you have to populate the input range. Now, it took me a while to figure this out the first time I did this, several years ago. But it's easiest for me to just kind of grab the entire table, including that blank spot up in the upper left-hand corner. So I go from A1 all the way down to D7 in this case. And then I make sure that I check the box that says I have the labels, and make sure you change the alpha value. For this problem, back in the Cengage problem, they gave me an alpha value of 0.1. So I changed the alpha value, and then I directed the output to be in cell F1, which I don't need to redo because it's already done. But that generated this table over here, which is your summary, and then down here, your two-factor ANOVA table. Now, if you just try to type these numbers, round them to two decimal places, and type them in over here, you'll wind up getting, the bottom top two of these wrong, and the bottom two will show up correct still, but you'll get all of these other things wrong. Because what's happening in this particular problem is that the treatment is the system, and the blocks are the different controllers. And so when you go to run the test, it shows you a ANOVA table with rows and columns, and it put rows first and then columns second. But what the question it asks you for over here is treatments in the top row of the ANOVA table, and then blocks in the second row of the ANOVA table. So they really want the columns to be the treatments, and then the rows to be the blocks. So you need to switch the order of the sum of squares when you're typing them in order to get the correct answer over here in MindTap. And then when you get to the F value, you notice there's actually two F values. There's one where you're using the rows as the treatment, and there's one where you're using the columns as the treatment. So make sure you pick the one where you're using the columns as the treatment, rounded to two decimal places. And then later in the problem, you'll want to report the P value and the F critical value. And then you can compare, as usual, the P value to alpha, which it is less than alpha in this case, or the F value to the critical value, it's bigger than the critical value. Both reasons why you would reject the null hypothesis and then reach a conclusion that there is actually a difference in the three different workstations, which is your treatment. All right, so that's just a quick overview of getting through a couple of little tricky things on 13.4 Excel Activity 1. Talk to you again soon.